When we create mechanical drawings, we always do multi-view drawings, also known as orthographic drawings, so that machinists or fabricators can read them and build what we have designed. Now, there are other kinds of pictorial drawings, perspective views, isometric views, and so forth, and those are good for representing several sides of an object on a piece of paper. You'll see views like this in a user's manual or a parts manual. And those are good for untrained readers, but the problem with them is they don't show any of the sides' true size and shape. And that's what our machinist and fabricator needs. What we will draw is a multi-view or an orthographic drawing like this, like let's say top, front, side view. It shows each side of the part all by itself in true size and shape, and that's what our shop people need in order to make our part. Now, not everybody knows how to read these drawings. Your ordinary, let's say, IKEA customer maybe doesn't know how to read those drawings, but anyone who's a machinist or a fabricator has training in blueprint reading, and it feels pretty comfortable with these views. The word orthographic comes from two Greek words, ortho, meaning perpendicular, and graphic, meaning writing. So orthographic means things that are written or drawn where the line of sight is perpendicular to your computer screen or perpendicular to your piece of paper. And the key idea, the reason we are doing these, is that we can show each side of a part true size and shape. And as we'll see a little later in the term, there's an ASME rule which says you must dimension features in a view where they appear true size and shape. So down here at the bottom you see other views like an isometric view or an oblique view. Those are good for people who don't do blueprint reading, but there's no way to put a dimension on that round slot there. So we're going to do orthographic views all term long. A key to being able to visualize your orthographic views and draw them correctly is this idea of the glass box. And to think about this, you imagine that the object that you're drawing is sitting inside a box made out of glass. And you get yourself a marker, you know, it could be one of those dry erase markers like you use on a whiteboard. And you come around to the front side of the box and you look straight at the box. Your line of sight is perpendicular to the glass side of the box. And you trace with your marker what you see. And from the front, in this part, you would just see an L shape. So you trace that. Then you go round to one side, and now you're looking straight on at the end of the box, and you trace what you see. And here is what your view would be, so that's what you trace with your magic marker. Then you go up to the top of the box, and you look straight down, and you trace what you would see. And here's what the top view would look like. And you do that around all the sides of your glass box. Now you've got a glass box where there's a part inside, but each side of the box looks totally different from each other side. Now you unfold the flaps of your glass box, and unless you have an actual glass box or maybe clear acrylic plastic box, you are visualizing this in your mind. So in your mind, you unfold these flaps that you imagined tracing, and you wind up with up to 6 views of this part, because there are 6 sides to a cube or a prism. So here's the front view that you traced, here's a side view that you traced, here's a top view that you traced, and maybe you have some others, and maybe you don't. Depends on how many views you need. Notice how As a result of tracing all these sides of the box, it turns out that all these views are aligned, like the side views and the front and back views are all sitting on the same bottom line. And that is a key idea in drawing these multi-view drawings, these orthographic views. Your views must be aligned always. If they can't be, you need to do something special with view arrows and labeling them. But otherwise, you must have these views lined up because you made them by visualizing the part in a glass box.